Ooh, infinite regress.
Yeah.
Nice way to start.
Okay, seems to be recording. So, hi everyone. Thank you for joining. I'm coming back on all the evolutions on the platform that we made the past 2 years. For a quick, I think only Dan was attending the first presentation 2 years ago that I did on the platform. It was the plan of what we were going to do for the next year.
Mm-hmm.
It actually took a little bit more than 1 year because we do not did everything that we had planned, and it took 2 years to do less that we planned. But still, we did a lot of things.
Yes.
So let's go back in 17, sorry. What we had. So we had one database server, 37 pools. This is like clients, almost. And we had 3 files that contains all the database scripts to update the database during release. When we did an update, it took us 1 hour. It was really not easy to migrate database. Everything was done manually, and it was with errors most of the time. Today, with the same configuration, if we did everything manually with 55 pools and more than 25 files, it would take 12 hours to do exactly the same.
Sorry, what's a file in this case?
It's really a file like an Excel file or something, but it's a script file containing all the scripts that need to be run on the database to update the schemas and the column and tables that contain it. We also had to update the platform, so we did it manually. At the time, so 2 years ago, we had 10 servers. We did using FTP upload, so it's a manually process where you copy and paste. We did that 10 times, and it was taking around 45 minutes. Today, for the same configuration with more than 50 servers, so it's 50 only for the production environments. It would be more for the integration and staging environments. It would take 4 hours to do exactly the same. We had to update the artifact. So the artifact is really the application that is packaged and that brings all the bugs, the features, and everything the product wants to deliver to production. The R&D package it in a form that we call an artifact, and then we can deploy that artifact. It took a lot of clicks, more than 200, and it was taking around 1 hour. This is a small joke in French for the previous meeting, but yeah, it's today for the same configuration, it would take more than 40 hours to do exactly the same. This is clearly impossible to do in current dates because the number of release that we do, like more than, it's almost 1 release per day. If we had to take 40 hours to deploy 1 release, we won't be able to keep up the tracks. So here, 2019, where we at? So we bring automation, and let's dive into this. So why automation? We can improve product delivery. So we see that with a release taking more than 40 hours, it's not possible to be fast. It also prevents human errors. So 2 years ago, like every release, there was some errors because we did something manually. We forgot one server. We mixed up files. We did something wrong. It was only human, and we can prevent that using automation. And repeatability, the good thing is that we have multiple environments. So we have staging, integration, and production. If we do one thing manually on staging, we have to do the same thing manually on production. If we automate, we can be sure that it's exactly the same thing that we did on staging that will be repeated on production. So now the question is, what can be automated? So the ones that were in the Roman presentation during the last year kickoff already know that kind of things. It's really important to understand that when we want to automate something, we need to think the whole cycle of automation. And it's not only the release that we want to automate, it's really the whole part. So we need to automate the building, we need to automate the testing. That's why the QA start to automate everything. And we, of course, want to automate the release, the deploy, and even the things after, like the monitoring. If we have to manually create some probes to monitor when we deploy something, it's not efficient because it takes time. So let's go back in between the difference in release versus that's fine. In release versus deploy. So first we get the source code. So that's what the developers are creating or developing. Yeah. Then from that source code we create an artifact. The artifact is something that we go from the source code, we package it in certain way, and then we get an artifact. This is what we call the release process. Then, once we get that artifact, we can deploy it on the server. This is what we call the deploy. This is what we call deploy process. So, just a quick question for you guys. Do you have an idea of what are currently our artifacts? So this is mostly for the developers and more for you.
Yeah, but I was going to go with no.
If you want to try and guess something, you can. You're free.
Is something the RAR file that is developed?
That's one artifact, right?
I was a developer for a long time, so
sure.
I know these things.
So the WARs, exactly, it's one of the artifacts, but it's not only the one. We have a lot of more.
Bomb jar.
Jars.
We have that. Those also are getting uploaded to Nexus, right? The commit message for verifying that the var is in the right. We generate an SSJ based on the var. That's right.
Like a checksum or something?
Yeah, checksum.
All right.
Yeah.
You're right. So it's not only that. We have a lot of artifacts. What we call artifacts, it's what we have to be deploying it on production. That means, yeah, we have the vars, we have the jars, but we also have graph, which is an artifact. It's all the CSS and like all the themes that we have for the UI. We have TD data. This is something well known for the developers. We have all the passwords that we need to deploy securely on the production. We have the Tomcat, the JDK. This is the infrastructure that we need to deploy so that the application can run. Some configuration keys and everything. So it's not only WARs, but there is a lot of things around it. So now I will explain how we can automate everything. So no, it's not magic. Everything is based on the tools that we have and that we put in place. So the first tools that we really use a lot is Jenkins. I think that the developers are really familiar with it, but for the others, Jenkins can schedule jobs. That means when you have a task to do, you can tell Jenkins, okay, do that once a year or once a day or every minute. You can schedule all kind of tasks. It can also listen to events. That means when someone do something, for instance, they commit something on Git, there is a Jira that is going from a new state. Jenkins can listen to that change and react by scheduling new jobs. This is really powerful, and there is notifications. You see a lot of the times on Slack, there is some notification from Chef, from database and everything. It's in reality, it's Jenkins that creates the notification and sends it to Slack automatically. It's not someone that writes the notification every time. Okay.
Just one question. So Bitrise is the evolution of Jenkins, or because mobile TV we are discussing something, Gabriel, but
sure.
I don't know the details.
So Bitrise, it's more like Jenkins is very general. You can configure everything, you can do almost everything, but you have to configure it, install plugins, do a lot of manual configuration to do what you want to do.
Right.
Bitrise is more mobile focused, and everything is already pre-configured to build and do the automation for the mobile.
Right.
And that's why the mobile
device
want to use it, because they have some configuration done that is really specific for the mobile and that works for them.
Okay, so it will be only for mobile team, not for the other teams here.
Yes, the Bitrise will be only for mobile.
Okay.
Yes. Second tool that we are using is Nexus. So the same Nexus is more developer focused, but it's an artifact repository. This is where we store all the artifacts that we are generating, that we want to deploy in production. The good thing is that it's a central storage. That means when we want to deploy in 50 servers, it's good to have all the artifacts that we want to deploy in a central place so that we can easily be accessible on all the servers that we want to deploy. And the good thing that it brings is access control. This is more for PCI DSS, SSAE, because artifacts are the business of TravelDo, and we need to protect them and to have some kind of restriction on who can access it.
Mm-hmm.
The last tool that I'm talking is Chef. So Chef is the major tool that we bring the past 2 years, and this is what really helps us automate all the infrastructures and deployment changes. So what is Chef? Chef allows us to write all the infrastructures as code. That means when we want to configure a server, before it was manually editing files like in command line and everything, and it was not easy to reproduce. And Chef allows us to write all the configuration that we want to make on one machine using some code. So it's Ruby actually, but we will just write what we want, and then Chef make that change required to bring that configuration on one server.
Mm-hmm.
It brings also automatic tests. So it's really important to test everything and to be sure that the infrastructures is tested. And this is something that Chef can do. And the same repeatability, when you do something like writing a piece of code to describe your infrastructures, you can easily do it on one machine, but also on 200 machines without issues. So I'm really bringing some components of it, of how it works in more detail, because it will be important for the rest of that presentation. So Chef, we are talking about cookbooks. Cookbooks, what is it? Is like a small piece of code that can be reusable. We can think of a Lego bricks. That's declare how to configure a piece of software that we want to install on a machine. For instance, we have a cookbook for Java, for Tomcat, and for all other tools that we might want to deploy on one server. Once we have the small Lego bricks, we can assemble them and create what we call a policy. This is a policy declare what one machine in production will do. For instance, I've made an example of an expense servers. The expense servers need the Java, the JDK, the Tomcats, and the expense jar deployed. So this, when you kind of bring back all those three together, this creates a policy. We have a policy for all the teams. So we have a policy for infrastructures like the reverse proxy. We have policies for IO team, the conductor, for travel like REST service API, administration, etc., etc. Another very important piece of components in Chef is the data bags. This will be really important for the developers because I want the developers be able to create merge requests on the data bags when they need a change to happen in the production or infrastructures in general. A data bag, what is it? Is really a JSON file. A simple JSON files with some properties like global variables that help us modifying the configuration in production really easily, because developers can have access to those data bags, can create merge requests, modify the configuration like the properties. For instance, if you want to change the version of something, you can change the 2018.2 and change it to the newest version that you want, and it will allow us to deploy the new version in production. So what we have? We have a lot of artifacts to release that we saw in the first. We have more artifacts to deploy, and there is a lot of tools to do it. So I will explain how we did in TravelDo to bring all the tools here to bring that automation in Travel 2. Is there any question up to now on everything? No, it's not too obscure for you. Is that okay? So, so this is for more developers are used to it. So when you build a piece of software, you almost always have that kind of process. So first you want to code things, then you have to build it, test it. This is really important, and release it. Yeah, it's often missed that part of testing.
It's a sore point today.
Yeah. So, like when you are developing something, the R&D parts, they're coding Java codes, so it's really what they're doing in their day-to-day life, and some SQL scripts. With the Java code, we have to build it. That means we take the code that's written by the developers and we convert it in the machine code that's only a binary, non-readable code. That's what we call the class. Mm-hmm. After that, we take that class and that SQL and we test it automatically. Mm-hmm. So we use a tool that's called JUnit. It's very well known by the developers. Mm-hmm. It's used to automatically test all the code that is written.
When you say test, you don't mean that it's going to functionally do what the product person...
No. It could. But it's really a small unit test. So it's only testing a part. It's not integration test where it brings back all the components of the application together. It's really testing small parts.
So what does a failure look like in that case?
It stops everything. So the process is stopped at that point. And then you have one error, or you can have multiple errors saying, for instance, this method here should return 2 and we get a 4 instead. For instance, when you want to calculate the VAT in one expense,
sure.
you have to expect 2%, and instead it calculates 3. There is an error. So it could be really functional, but it's really at small scale. Mm-hmm. And we do the same for the SQL scripts. So when the developers write SQL scripts, we use it to test it on the database using Flyway. Mm-hmm. The next part is to release the code. The release process is to create artifacts. So here from the class Java code, we create jar and vars. And from the SQL, we create what we call a SQL jars, which is a very special kind of jar. And we also get our checksum that we need for SSAE, really. This is so a checksum. It's a piece that calculates like a summary of one big file, but it's translated in like 20 or 50 characters. And if you change the binary file, it will also change the checksum, so that you can be sure that the file is not modified if you check the checksum, which is easy to manipulate because it's a small string. Mm-hmm. And we also create a special thing which is called SQL POM, and I will explain what it is just after that. So we use what we call classified artifacts. Classified artifacts really is the SQL jar is a classified artifact. It's built from the same source code, and it's prefixed with a special denominator. That means the content of the artifact is different. For instance, the standard artifact contains the Java class. The classified SQL artifact contains the SQL source code. Mm-hmm. Here is an example of an organization module where you get the SQL jars that is highlighted, and you have also the standard jars, which is 4 lines below the highlighted one. Okay, so it's nice, but our job is to deploy some vars and not jars. The real application, we deploy vars because it's the application that allows us to display the interface to the clients. But inside the vars, it's built of multiple jars. It's like small modules that you want to aggregate into a big package containing all the dependencies, and the big package, we call it a var. So this is where the SQL POM comes in. The SQL POMs contain all the dependencies needed, the SQL dependencies needed to run the application. So how do we build it? We start from SQL, like an application developed by the R&D, which is a POM, and it's containing a lot of dependencies. We have some module that we call business jars. We have supporting business, and we have generics one. So this is really a small modules where you don't want to put everything in one single big source code because it would be too hard to maintain. So we split it in small business modules that are independent between them. And we package everything into a big WAR module that we call everything is tied up using the POM. So from the business jar and supporting business, we can create the classified artifact SQL version that contains all the SQL source code. And then from that, we can create a SQL business POM containing all the dependencies of SQL business and SQL supporting business jar version. And we do the same for generic version. It's POM, not PON, at the top right. This is more important for the developers to understand how we can deploy the source code that they write in the business module. They're very used to manipulate the business modules that are a business jar, supporting business, and generic. So the release process brings us SQL POM, so we get two different versions, one for the business modules and one for the generic modules. The difference here is that the deployment is a little bit different between the generic and the business modules. We do not run the SQL scripts at the same place when it's a generic or a business. And that's why we had to make that specific use case for the generic one. Okay, so now that we saw how the developers are doing the release process, let's talk about infrastructures. Mm-hmm. It really could be good if we don't have to reinvent everything that's working great for the developers. So let's do it. Infrastructures, in fact, it's also artifacts. So we can do exactly the same. We can do code, build, test, and release like we did for the code. For the moment, the platform team is writing some code. So instead of writing Java, we write some Ruby. Instead of writing SQL code, we wrote some databases. Mm-hmm. But it's exactly the same principle. The policy file, which represents the state of one machine in production, is compiled in policy.log. It's really a binary version of the one that is written. And then we take the databags and we compile everything and test it using Docker. Using Docker, that means we create a virtual machine of it, and then we reproduce exactly like we do in production.
So we're using Docker on the infrastructure side, but not yet on the code side?
No, we are using Docker on the test side, which is a little bit different. Okay. That means before doing the test, like the release on production servers, we have to test it before to be sure that everything will be working and there won't be any errors. So to do that, we start creating a Docker instance, which is like a virtual machine that we have in production. We run all the tests in it and all the modifications that we want to bring on the machines, the virtual Docker machine. And then we have a way to verify if the modifications are right or wrong. If it's right, then we can release it and deploy it.
My understanding of Docker is probably very light, but it's that with this, because it's an accurate simulation of what you will find on production.
Exactly.
You reduce a lot of final risk about.
Exactly.
Yeah.
It's like simulating what will be in production once we release it. And Docker is good because it's small, and then it's really fast, so that you can test like 2-10 times without having to bother to everything. And the next step, like in the wars, jars, and everything that the developers do, we create some release. We zip everything like we do for the wars, all the codes, and we deploy the databags into a special repository. So some pointers for the developers on databags. That's really important to know how do we use it in TravelDo. Because this is where I want to bring some controls on the dev teams on that part. You have a question?
I do, but I'll
Okay.
take it at the end.
Sure.
It's okay.
So context keys, artifact, batches, tenants, all of that kind of databases we have. Context keys, this is well known for you developers. This is where we store all the Tomcat configuration, which is really interesting when you want to check something. You have a special repository where you can check all the configuration per environment on Tomcat configuration. You also have another database which is interesting, is the artifacts and batch. This is where you can check all the version that is deployed on each environment. Among the package, the context path for the deployment and all the useful information. And you also get the checksum that we need for SSAE at that place. Another part is the tenants. We call tenants like all our clients, customers. For instance, we have a demo, we have Total, we have everything. All kind of clients are represented by one configuration file with all those configurations specific to that client. You also have one thing interesting for you guys is it's in there where you get the passwords for integration database, for instance. Everything is written in that configuration file where you can get the information on the database URL, database password, and username for one client. Okay, so if I sum up, I get some artifacts created from the R&D dev team, so WAR jars, SQL POM, SQL jars. We have also some artifacts created by the platform team, policy file, and databags. Also, the ones that we almost forgot is we have some zip file like TD data, like graph that we are often forgetting, but it's there and we have to release it. So now I will explain how do we deploy everything. So now we saw the release process, which was taking all the source code that we get, creating some artifacts from that. And now, once we get those artifacts, we can see how we will deploy it on production servers or all other environment servers.
I mean, give just one question. So you mentioned that this whole process is automated, right?
Yes. So this process is automatic and it's run on Jenkins. So
on
Jenkins do all that part. It takes the source code,
yeah.
It compiles it and creates the binary version. It tests it automatically and release it automatically. Some process might just be triggered by one click, and you have all the chain that is processed. And some others are really full automatic. When you change the source code, it automatically make all the chain and do the release process automatically without any human interaction.
Okay, so that's what happens when, let's say, when we do a release.
Exactly. So when you click when you say do a release, the developers click one button on Jenkins, and this is the process, all the process that you get on Jenkins.
Right.
And the database update for the jars which you mentioned, that is done by the ADGRs, right?
Exactly. So this is the same. We have a Jenkins job that take the source code and edit it automatically based on the Jira IDs that you get. Okay, so how do we deploy things? We get one really useful tool. It's called Chef Clients. This is really one tool that allows us to do everything. And I will explain how it's really quickly how it works. So the goal is to update one virtual machine running in production or staging, for instance, and deploy either an artifact from dev team or either an artifact from infrastructures. So the first things that the Chef client do is taking the policy. The policy is really the state of what the machines needs to apply. So this is the first thing that it gets. The second thing that the machines retrieve, it's the database. Because this is where all the configuration is stored. Without that, you won't be able to know which version deploy and everything. After that, all of that is stored in a repository that we call the Chef server. It's exactly like Nexus, but it's stored specifically for policies and databases. Once the policy is known and the database, like the version of the artifacts, are known, the virtual machines can retrieve the WAR or the jars that need to be deployed on the machines. For instance, when there is a new version that is ready, it will get the new WAR version from Nexus. And you can also have some new artifacts like TD data. When there is a new version of TD data, it also automatically retrieves the new zip file containing the new version of TD data. And all of that is stored in Nexus, so that it's a central place with access control, and it's easy for the machine to get access to that.
Gil, stupid question.
There is no stupid question.
Challenge accepted. Are all of our machines virtual machines?
Yes, almost. There is few exceptions. The only real not virtual machines is the database. The Oracle database is a physical machine. All the other ones are virtual machines that running on 4 big physical machines.
And then so the process to spin up a new virtual machine is quite efficient?
It's quite efficient. It's still manual, so that's why it takes a little bit of time to configure like the network part, to be sure to give proper authorization to access one service or another. But it's efficient, and you can create new virtual machines. That we do it regularly when there is new services that needed to be deployed on production. We create a new virtual machines, and then we can.
And is that new since 2017? The virtual machine?
No, it was there.
We already had.
Yeah, like when we were there, like maybe 5 or 6 years ago, there was already some virtual machines in there. The only real difference is that it was Windows machines with the UI, and you had all the manual things that you have to do when you want to change something, and all the automating process was made available because we migrate to Linux, and it was easier to automate.
So when we talk about load balancing across TSN machines, that's load balancing across virtual machines.
Sure.
Okay. Because presumably with virtual machines, you are load balancing at the level of resources, right?
Yes.
But this is...
You can have two different...
The other level of...
Yeah, but you can have two different levels. You can have one virtual machine hosting 2 TSN services,
right,
and you can load balance between those two. But you also can have a second virtual machine also hosting 2 services for TSN and load balance between those 4. This is also a possibility.
But the virtualization is different on Linux and Windows.
That kind of virtualization, no, it's the same.
Okay.
It's really under the hood. There is a physical machine running on Linux.
Yes.
And then you get your virtual machine.
Okay,
and
no, I asked the question badly. So we have Linux, mostly Linux now with virtualization.
Yeah, but no.
And then separately there's Windows with Windows virtualization? Or...
No, it's not like that. We have a Linux underlying.
Yeah.
It was there like 5 years ago. And inside on that, we have Windows VM virtual machines and Linux virtual machines next to it.
This is the kind of thing that's good with a diagram. And
yeah, it will be easier.
But I think I get it. Yeah. So.
Okay, so what about database? This is only the one thing that I didn't talk about it in the previous diagram. So this is everything based on Jenkins. Jenkins retrieved the SQL POM that we talked about, containing all the dependencies that one application requires to run. And it retrieves also all the SQL jars containing the SQL scripts that an application needs to run.
Our SQL, we run Oracle.
Yes.
The fact that we use Oracle and not some other flavor of relational or a non-relational, is that impacting to the developers? Do we abstract in some way so that if we change database, they wouldn't know?
No, they would know because they would have some functions that are not available when you change the flavor. So you would have to change the way you're developing, so they can't not know.
So we are quite married to Oracle for now.
Not married for it would take a very
amount
of work to change everything.
Yeah.
I think the fact that we are starting to make some small modules makes things easier to migrate, because You
It's
only have to change a smaller part instead of having
It's
to
like the
change.
microservices thinking.
Yes.
Yeah.
So it will be easier to migrate, for example, a small part of it,
Yeah.
and then do the next part after that.
Okay.
So that's easier the process. But yeah, it's not. I mean, the whole deployment and release process will not change at all.
Yeah.
But the development side would change because they would have to change the way they write the SQL queries and everything.
I have to go in a few minutes.
Sure.
So maybe I can ask my questions now. So you have the nice arrows where we build code, test,
and
release,
release.
blah, blah. Rollbacks.
It's not possible. It's not in the plan. Actually, it's yeah, we do it.
It's not against the physical laws of the universe. Other people do it. You mean for us right now?
So how do we do it? It's really exactly the same path.
Yeah.
When we want to roll back, you just do the same process, but using a different version. This is what we call. In fact, for us, a rollback is just deploying a new version. Maybe that your version is a previous one, but for us, it's like a different version, and we deploy it like any other version.
But when we write the kind of deployment scripts, we don't write a rollback script.
No.
It's just you go there. If you need to go back, you work out how to go back.
So this is for the developers, right? They have to make some changes, but on the release and deployment, there is absolutely no differences. It's just a different version.
So for the database rollbacks?
And the only, so the database is always the exception. We do not roll back the database because there is a contract with the developers that when we make some changes for a new version, it needs to be compatible with the previous version. So if we roll back the previous version, the database will still work with the previous version. And then we just have to wait the new release of it.
Okay, so one more question.
So what about the update in columns? Because we have some update scripts.
That can be executed by RFCs.
No, I meant like for rollbacks of update queries, do we have plans?
On our side, we do not have any plans because the way is to not roll back the database because it's too complicated. Like 4 years ago, we used to have things to create all the queries to roll back the database and everything. It was crashing every time we needed, so we stopped doing the work twice. And just be sure that when we create an update, it needs to be compatible with the previous version. This is the mechanism that is in place to be sure that we can roll back an application without having to roll back the database. And for your case, this is a special case that needs to be handled as you want. For instance, running a RFC, running something, having some application fixes that can handle all the cases and everything.
So is there any option in Flyway scripts to have a rollback script also?
No, Flyway forbid it because it's not in the agile way of thinking to roll back. The thing is always to go forward and not to go backward. So Flyway does not have any rollback option.
They just don't make mistakes in their company.
They do. We do make mistakes, but you can make a fix for your mistakes instead.
Different philosophy.
Yeah, sure, of course.
Then the last question was just for the things that you're talking about, the evolution at this level with DevOps. When we think about wanting to be in the cloud in the future, are there things where there's really 10 boxes and we've ticked 7 and we still have 3 to go? What's the kind of cloud preparation filter on?
So it's a little bit different. All of that would help if we want to migrate to the cloud, because all the automation that we did allows us to create a new machine on Amazon, for instance, and having everything automated, we just click one button and we have the machine that is ready, configured, installed, and everything on the cloud. So this will help if we want to migrate. But the cloud migration is not only blocked by that, and there is other blockers. Like the dependencies and everything, the contracts and everything. So it's a little bit different. But this helps when we will be ready to move to the cloud. This will greatly help because everything will be.
Is there anything in your domain that is not done that we would need to do?
No.
No.
Okay. At that point, we are arrived at a state where we are confident and everything is ready to move to any other providers that we want.
Thank you. I will try to watch the last minutes.
It's alright. It's almost done, so it's okay. So let's go back to the SQL migration. So we took all the SQL POM, SQL jars from Nexus, and then we apply it. So the first step is to apply it to a schema database that is only done for testing. It's called SCHM. This is a blank database without clients on it, and we just run the SQL script to be sure that the scripts are working. This is a second level of testing. And then we run all the SQL scripts contained in the SQL jars on the client's schemas. And everything happens in the database. Okay, so the summary, we have Jenkins. It's released all the artifacts. We also have Jenkins used to deploy the artifacts using the tools called Chef Clients. And then the last thing was to update the database. It's still done using Jenkins and using the Flyway tool. Any question on that part? Anything?
So Guillaume, I just have a very general question. So we've been hearing, at least on the mobile team and in agency, we've heard lots about continuous integration, continuous delivery. So clearly that is not possible now. But if we were to move in that direction, what are the impediments and?
So why do you think it's not possible?
I have no. So the thing is that you've clearly demonstrated a lot of things that needs to be done, and I think that there must be a sequence to all of this, and there must be some kind of checks which needs to be done.
So there is two different things. The first thing is if you want to deploy continuously in production, then
RCGs also.
That's a process. Of course, you would have to create some checks. For instance, the QA for the moment still does some manual testing.
Right.
That can't be that can be automated, but they are in the process of doing it. Until now, it would be hard to deploy in production without be sure that what you are deploying is fully tested.
Right.
So this is the first blocker. But let's take the integration version for the moment. When one developers click one button for creating the release, so creating the artifact, then all the process is automated, and then the release and integration is also fully automated. You just have to create one Jira ticket, and then everything is automatically updated, deployed on integration, restarted, and you have your environment ready. So to go that, the only two manual actions that we have for integration is creating the release, and the second action is to create the Jira tickets. You could automate those two parts for integration. For instance, instead of having to click on a button to release, you could say, okay, as soon as someone make a merge request, it automatically creates a release. That's possible.
Yeah.
And the second thing would be, as soon as there is a release ready, an artifact ready, you create automatically the Jira tickets for that release. And if you do that, everything would be automated. As soon as someone creates a merge request, it will be deployed in integration.
Integration, yes. So what you explained to me looks very simple. So let's say if we were to move in that direction, so it's just more of that we have to organize in terms of in the organization, or where various team needs to have this kind of philosophy. Because the part that you mentioned, there are a couple of automation that needs to be done. So it's just getting the leads in line and having, and it seems possible.
For me, the choice of, for instance, releasing every time someone do a merge request, it's the team decisions to do, okay, we are confident when we create a merge request to automatically create a release and then create the tickets and deploy to integration as soon as it's ready, because we are confident of what we deliver.
Right.
Now, the things that could be added to more security is to make some automation with the QA. The QA prepares some automation tests that can be run after one release. This could be also something that could be automating. So when you create one release, you try to deploy it on the test servers. You run the QA release checks on it, and then if it passes, you deploy it to integration. If it fails, you do not deploy it to integration. That's a possibility, and for that, everything is ready. All the infrastructures is ready. The only thing that need to be changed is more the development parts on the dev teams to be ready to make some merge requests, automate the parts to automatically create the release and everything.
Okay. Right. So because the part that you mentioned about QAs, manual checks, so as you mentioned here also that QAs are working on creating automation.
Sure.
So I think that would be one step in that direction to achieve continuous.
And they are working really greatly on that direction to improve all the manual tests they do and instead creating the automatic version.
Okay. So I think it's moving in the direction. I have another question, but totally different to. So we in the application we need localization in various languages. We are growing in different geographies. So for that, the process is completely manual. That the developers extract the xlib file or .properties file or XML file, and the product manager send it to the Expedia project manager for translation. But she told me that in Expedia, other group companies, they use GitLab. And from there, they could, so let's say a developer, whenever they do a check-in of the code, there is some connection where the translation team receives the new lines basically that were added for which translation is needed, and they would automatically provide the translation and send us back. So of course we want to move in that direction. So maybe if you wish, I can maybe set it up with some time with you to discuss this.
I think it could be discussed in a separate meeting, but this is really in the kind of automation that could be done. Since it's only a Git things, so it's more a developer things. So this is something that you could only work with the developers,
right?
So that they can plug whatever tools the translators need on Git, so that every time someone make a change on Git, it automatically sends the difference and everything. And this is possible. For me, it's only a developer
thing. It's not at your side. Okay, sorry.
For me, there is no interaction. Maybe there will be some right permission or access,
but
once
because
it was actually a different tool which we used previously, and it was not on GitHub. Are you sure?
Yes, I'm quite sure about that.
GitHub was used to save the final translation file as well as the source English file, but the workflow that managed notifying the translators as well as of the changes and getting the translated file into the GitHub was done through a separate tool.
Right.
I don't think it is GitHub alone.
So I'm in contact with Francesca. She's the project manager. So she said that for other group companies, that's the process. Of course, I don't know the other details. And
tool also.
Indeed, there are a lot of other things, but I'm of course oversimplifying it. But because currently we're doing manual, so even if you do a small thing, that would be helpful with automation.
In Orbitz, we used a workflow tool called Transifex. That they had some license for some million words at that time.
Right.
6 million words.
Okay.
That's what I remember. So
if you want, let's plan a meeting to discuss about that.
This thing, yeah, sure.
Because it's not finished.
It's not. It's not finished. Okay, I thought it was finished.
No, it's okay. So the last, it's a small part. It's more about scalability. So this is more general. So what we did previously, we did a manual load balancing. So this is what I called it. We had like 55 pools and 70 servers on all the environments. And this is what it was looking like to bring some URLs like w1.traveldo.com and w5, 2, 3, 7, 6, and all of that into the servers on the right. It was a real spaghetti mess that, as you can see, and there was some URLs that was going to multiple servers. Some of it, with exceptions, are going to one server, but not all of it. And everything, it was really hard to maintain. So instead of that, we invented Tetris before it was cool. So instead of that, we made some software load balancing. What is the software load balancing? So the goal is to have some machines, virtual machines on the right, and we have internet where the users are coming. The manual load balancing is when you come from internet, you either get to the virtual machine 1, 2, or 3. This is really hard to manage because when you want to switch one user to a second machine, you can't. Instead, you have to ask the client to change the URL, which is very not convenient and very hard to do. So the first step was to put instead a reverse proxy. The reverse proxy is like instead of all the clients arriving directly on the virtual machines, it's a single entry point. This allows us more flexibility on redirecting some clients to one machine or another. It's still manual because we have to decide where the clients are going manually, but it's an improvement. The second thing that we added is a load balancer. So a load balancer, instead of talking directly to machines, we are talking to applications. And we can split applications like in the same kind. For instance, there is two kinds of application in the diagram. We have like the purple ones and the blue one. And all the applications are registered to the load balancer. And the load balancers take care of sending the clients to the right applications when they need. And even more than that, for instance, when there is one application that is not responding, the load balancer takes care of sending all the clients to the applications that is responding. Of course, if the application is of the same kind. For instance, let's consider the purple one is the travel application and blue one is the expense application. If one application travel is not responding, the load balancer automatically sends all the clients to the working ones without any interruption for the clients. So this is an interesting part. So it's only available for developers. So, sorry. This is a status page where you can get all the machines and applications that are registered to the load balancer. And you have some nice stats about it. You can get, for instance, the number of sessions each machine currently have. For instance, this is an example for travel application. And you see that the number of sessions on each machine is very consistent. You have 8, 9, 9, and 13 for the last one. But globally, it's really consistent. So what's next? Kubernetes and Docker. So we already starting using it for testing. The goal now is to see how we can leverage it to deploy faster the application on integration and development zone. So this is what we are currently working with Agentia to see how we can speed up the deployment process more. And this will really come handy for all the developers that want to try some beta versions before going to integration. And a small word about our teams, the platform team. We are some developers team like all others. We create artifacts like all other teams. We create and we deploy artifacts like all other teams. And we do accept merge requests. All the artifacts that we are creating are on GitHub or GitLab for the moment. You can have access to it, and you can create merge requests when you want and when you need to. Thank you. So if you have more questions, I will be happy to answer it. And thank you again.
Yeah, thanks, Kim. That was very helpful.
So no question?
I'd have to challenge, Dan's question of let's go with the stupid questions.
Yeah.
No, I'm kidding.
No, that's fine. Okay, I will stop the recording.